Welcome all brilliant engineers to another episode of Bastukar. I know this is feeling a little bit spooky, but this is how it's going to be from now on. Time has changed and the way we used to learn is also changed. Bastukar is determined, you all know, to break the hard and tough theories of civil engineering into a very easy, understandable form so that you can chew it just like a chewing gum. I'm Engineer Ranadip Chakraborty. You're watching Bastukar. Today is the day of another video, a special episode in continuation of the series of the bar bending schedule. The second video of this series, as I have promised in the last class or the video, is coming just right after this. So let us look at the presentation over there. So let us start the second video of this bar bending schedule series. Today we are going to learn how to derive the formula to calculate the weight of any dia bar. This will be very much handy in your exams, also in preparation of the bar bending schedule. In my personal life, I have experienced in an interview that an interviewer was asking me some questions regarding how to derive the weight of reinforcement, and he was not in agree with my answer. So I put my derivation on paper before him and he was very much amazed with me. So you must build the concept as I am always telling you guys. Let's check on what's coming next. Some preliminary knowledge you must know is that 1 meter equals to 1000 millimeter. Therefore 1 millimeter will be equal to 0.001 meter. The density of mild steel, it is 7850 kg per cubic meter, and some notations which I am using, that is small d, that will be dia of reinforcing bar in millimeter. Or if I am converting the millimeter into meter, it will be coming as d millimeter equals to 0.001 d meter. Let's crack it. Let us consider a reinforcing bar of 1 meter long and diameter of d in millimeter. As I marked this as dmm dia. So volume of that 1 meter dia bar will be simple, the cross sectional area of a circle, as the reinforcing bars are in circular cross section, and its length, therefore pi by 4 into d square, as we know the cross sectional area of a circle. So it will be coming as pi by 4 into 0.001 multiplied by dmm and square of it. I have multiplied it with 0.001 because I am taking the whole thing into metric system, that is in meter form, or ultimately we will be taking it as cubic meter as volume, multiplied by 1 because 1 meter is the length. So area into length, it is coming as so and so cubic meter. Weight of bar, so we know the weight of bar will be the volume multiplied by its density. Simple. So the volume we already know, pi by 4 multiplied by 0.001 dmm whole square multiplied by 1 into density 7850. So if we do calculate these things, it will be coming as 0.006165 and it will continue like this, d square mm. So we can simply write it as 0.00617 d square, where d is in millimeter, or the dia of reinforcement is in millimeter, or you can also write it as d square divided by 162.2. There are many things written in different books, but this is what we are getting over here is the actual precise calculation. As you can see, we have derived it mathematically, so there is no chance of any kind of error. I have also noted the weight of some commonly used dia reinforcing bars in this table. You can look into it, you can just take a screenshot of it. I am not reading it out because it will make the video unnecessarily lengthy, and I am also rounded that figure. You can do the same with the formula. Hey engineers, I hope you have liked this video so much, and it was pretty interesting to know how to get to know weight of any diabar. Okay, you just don't need to remember everything every time if there is a formula, and also if there is someone like me with you. So please do subscribe to this channel if you have liked this video, and don't forget to share with all other engineers. Till then, always feel proud to be a civil engineer. Thank you.